Alright, working together problems. Crewton Ramone's houseofmath.com using Screencast-O-Matic for my screencasts. It's super cool, easy to use, totally functional software that lets you do 15 minutes worth for free in the free version. $9 gets you a version that'll go, you can go for an hour if you want to. And like completely intuitive, easy thing to use. Like you'll get this thing and it'll be like 5 minutes and you can be having screencasts to your little heart's content. Working together problems. Here we go. Let's get down to business. What are we doing here? Well, first, we're just going to apply the 5 concepts. 5 concepts in math. Math, study numbers. All we do with numbers is count. Highest number to count to is 9. We only count stuff that's the same. Numbers tell you how many. Places tell you what kind. Or a number has 2 parts. The how many part and the what kind part. We form rectangles to facilitate the counting. In other words, we form rectangles to make it easy to count. 0 and 1, that's it. Right? Here was 0, no fun, get back to 1. So let's apply those concepts to this simple problem, and this is what you usually get. You get something like this. Mary takes 3 hours to paint the house, or paint the floor, and Bob takes 4 hours to paint the floor. So that same floor. So if they work together, and they don't get in each other's way, and everything goes exactly perfectly, no, just kidding. If they work together, Mary takes 3 hours, Bill takes 4 hours. How long does it take them working together to paint the floor? Alright. First thing, no fun, get back to 1. We know about 4 hours worth and 3 hours worth, but we don't have a point of reference. We don't know how long it takes them to get 1 hour's worth of work done. And that's all problem solving is, really, is using the information we have to discover the information we don't have. I'll repeat that because it's vaguely important. We use the information that we have to discover the information that we don't have. And we need a point of reference. No fun, get back to 1 takes us to that point of reference, which is how much work does she get done in 1 hour? And how much work does he get done in 1 hour? We have fraction styles that can do this, but here's a quick picture. Just a quick sketch is just as good, see, and then we can use the symbols. Later on we get the little kids to understand that the reason why we use symbols is because it takes too long to draw pictures. And if we know what the symbols mean, then it's really easy, and they represent these pictures. So here we have Mary in 1 hour. 1 hour's worth of work, she gets a third of the job done. It would take her 3 hours to get the job done, so using simple logic, 1 hour's worth of work is 1/3 of the job. Bill over here, same thing, takes him 4 hours to get the job done, so he would only get 1/4 of the job done in 1 hour. So now we know how much it takes them to get, how long it takes them, or how much work they get done in 1 hour. Now, next thing, how much work do they get done in 1 hour if we get them working together and add them together? And you can really see here the blocks really mirror physical reality, or the symbols. Because what we have to do is understand that we can't add stuff that's not the same. This is the numbers tell us how many, the places tell us what kind, or the number here, how numerous it is, denominator, the name of it, denominator, 1 of the thirds kind and 1 of the fourths kind. Can't add those two. Also, do you see that the numbers here actually mean something in physical reality to the student? This 1/3 isn't just some fraction, and it's not just some algorithm of add them together and multiply and do this and do that to get the answer. It's understanding what they're doing, the concept of what's happening. And then we can give them any problem, and they can get it done, because they understand the concepts. So, 1/3 and 1/4, we have to convert that into 4/12 and 3/12, and there you can really see 4 of 12, see that? And there's 3 of 12, and we add them together, and there's a little more algebra we could talk about there, where we have 4 plus 3 over 12, but we'll skip that for now. But for you guys, I'll just throw that in there so you can see, so the teachers can see where some of the symbols where these symbols come from. So here we have 4/12, 3/12, that's 7/12. What does that represent? That represents 1 hour's worth of work. Her 4/12, which is the same as 1/3, and his 1/4, which is his 3/12, added together gives us 7/12. And there you can see we toss those aside and put a 7 in there. So now we have 7/12 added together. And now we can see a lot of kids will try to represent this in terms of the 12th, when actually it's in terms of the hours worked that we need to represent the answer. So how much time does it take them? Well, 7 of the 12. And then this is 1 hour's worth of work. This isn't an hour's worth of work. This is 1 hour's worth of work. So I need to take another hour and figure out how much of that hour do I need to complete the entire job. And see how they're, again, the blocks or the rectangles just clarify our thinking. Now, do I need the whole next hour, or do I just need a portion of it? Well, obviously I just need a portion of it. And what portion do I need? I need 1 hour and 5/7 of that hour. Not 5/12, 1 and 5/7. And they can see why that is, because we're talking about this hour, the unit of time, not the unit of job. Okay, so 1 and 5/7. There it is, done. And now for the older students, we have to convert that into minutes. And it's just very simple straight across multiplication. And this one didn't come out easily at all. We just had to multiply 5 times 60. And what is that, 60 over 1, right? Times 5 times 1. Okay. So, again, just a little bit of arithmetic. And we come up with 43. Simple. 43 minutes. Actually, it's 42.8, but we rounded it up. Right? It's 300 divided by 7. And you see where the arithmetic shouldn't slow you down? If you're a little kid, doing this portion is not appropriate, right? If you're 5, 6, 7. But if you're 5, 6, 7, you can certainly understand the concepts and get this much of it done. Get to the 1 and 5/7 portion. Okay, and for the older students, we're going to have to put in that hour part. And then you do lots and lots of these to practice. Lots and lots and lots. All right, on to the next problem. So, like I said, many problems for the little kids and for beginner students. Older students will pick it up quickly. Younger students, you're going to have to do more examples before we get to this point. And especially, you don't want to just do one. You can do at least 3. What we're going to do is show how we move to mastery here, where you can master the problem and get it done very quickly once you understand the concepts. And then the algorithm makes sense. So here, didn't use blocks. Very sloppy symbols, but just using the symbols to understand what we needed to do. Well, we have, let's take Bill and Ted. Bill, who's obviously an expert at this job, and Ted, who is not quite as good because it takes him 2.5 times longer to get the job done. How long does it take them working together to do whatever it is? Make something up, paint the floor, paint the house, do yard work, write a paper together, build something, etc. Use your imagination and make up these story problems. Usually it's paint the floor. That's what they usually come up with. So let's get creative and say they're writing a little computer program. It would take him 2 hours to get it done. Or how about this? Building a web page. Take him 2 hours to get the thing done. Take him 5 hours to get the thing done. How long if they're working together? Well, here's 1 hour's worth of work. He gets half the job done, right? Because it only takes him 2 hours to get the job done. So in 1 hour, he'd get half of it done. 1 of 2 portions done. And he would take 5. That's Ted would take 1 of 5. So he'd get 1/5 of the job done to get it to finish the job. So we can figure out if we add the two together, and that's what this is with no symbols to tell you what's going on, is that we added 5/10 and 2/10 because we have to get common, find how much work it is. 7/10, and once we got 7/10 together, that's these two added together, we get 1 and 3/10. And 3/10 is really easy to convert into an hour because we can cancel right here, right? Simple rules. All right, so 18 minutes. Let's see, later on we'll do fractions and we can talk about why it is that why that works. And it's done. That's it. No blocks, no anything. Just did the math using the symbols. Now we move on to another one. And like I said, you want to make sure with the small children you do many examples. You'll do at least 3 or 4 using the blocks, and then another 3 or 4 or 5 limited amounts of blocks and symbols, and maybe just drawings, and then symbols and drawings, and then you move on to where they just use symbols. Here we have an older student who has a pretty good knowledge of mathematics, so we can breeze along and just do a few problems. And see, the algorithm that you can see in some books that'll tell you, add these two together, then multiply them, and then do some division. Well, now it makes sense. Instead of just having an algorithm, we know what to do, and we know what that 9 means. That 9 means their work together. That 20 is the job, the total job, right? Not just a couple of numbers and a fraction where we, have no understanding of what we're doing. And I can relate these symbols to the blocks. Here is the total job, 20. There is 9/20ths of the job, right? Their work together. And then here is another hour. Still not done. And then we need one more hour, but we don't need all of it. We only need 2 of those 9 parts. And again, it's not 20ths because we're talking about the hours in terms of the hour. Many students get messed up at that point, and they'll come up with 2 and 2/20ths. But it's not. It's 2 and 2/9ths because we're talking about their work together. And now that's clearly understood because we've done a few problems and they can actually see what's going on. See how quickly we can master these kind of problems? Simple, easy, using basic concepts. And there it is. Now we convert, right, to the hour. Simple, taking 2/9ths and multiplying it by 60/1 to get our hour. And doing some canceling again to get 40/3. And then that becomes easy to do because the numbers are smaller. And that's why we like to cancel. Alright. 2 hours, 13 minutes, and a third. Alright. Now, change the problem. But you see, look, move to mastery that quickly. Really can. Now, a problem with no fun, get back to 1. Again, basic concepts again. It's always those same 5 concepts. I have 12 donuts, and it cost me $3.60 for those 12 donuts. They're the small, mini kind of donuts that are so delicious. How much would it cost me to feed a donut apiece to 35 kids? How much would it cost me to feed a donut apiece to 40 kids if 12 donuts cost $3.60? Well, once again, what do we need to know? We need to get back to a point of reference. We need to find out what 1 donut costs. So here we are again. No fun, get back to 1. And here is the attempt at figuring out that it's 30 cents. Actually, it's not an attempt. He did figure it out, but couldn't figure out how to move the decimal places. And I just think for a moment. And he was able to see, oh, 30 cents. Okay, so if 1 donut costs 30 cents, then how many does 35 donuts cost? Well, that's very simple multiplication, right? Done. Just simple thinking skills. Now we get to the point where we understand what's going on and fail at the arithmetic. Watch my videos on cross multiplication, because here's what happens. You see kids, they'll be able to 0 times these, and then 3 times 5. That's not 3 times 5. That's 30 times 5. So where's my $1.50 down here? Or where's my 150 down here? It's missing. And it's not 3 times 3. That's 30 times 30. So this is where I really have a problem with teachers that, say 3 times 5 or 3 times 3, because it's not. It's 30 times 30. It's 5 times 30 or 30 times 5. And many teachers will give, even at MIT and Stanford and all of our best universities, they'll give partial credit, right? Partial credit for calculus problems. You got some of the steps right. Was the final answer correct? No, the final answer was not correct. In my class, you get 0 credit for that. Nada, because that's not the right answer. And anyway, I could go off on a tirade about how our standards have fallen in the United States, but we won't. And UK and Canada as well. Just trying to pass the students because we don't want to look like we don't know what we're doing, and we wind up compounding the problem. Anyway, got this one right at least. No problem, right? Just 0, 0, 3 times 4, 30 times 40. Oh, and we're done. Okay, so, and this is a 17-year-old autistic student who supposedly can't do math. They weren't even going to teach her math in school, so the parents hired me. And here we are doing completing the square and having a fun time, with algebra. But anyway, concept-based teaching, using the 5 basic concepts and applying them to story problems. Makes it super easy, super fun. You can reach mastery in no time. And when you understand what's going on, it's easy and fun. Crewton Ramone's houseofmath.com for more.